Hi, welcome to Physics Teacher. In this video, I'm going to go over the solution to a grade 10 math contest problem. It's question 24 from the Cayley contest in 2020, and it's a fun one. So give it a try, and I'll be right back with the answer. Okay, so in this question, we have a cube where each side length is 200. Point P is on this side here, HG, and the shortest distance between G and a point inside this triangle, PFM, is 100. So we can actually draw that in here right there. And the shortest distance would be perpendicular to that surface, like so. And then the question says, which of the following is closest to the length of HP? So I have to figure out what this length HP is. All right, so first thing that I'm going to do is I'm going to call this length PG X. And therefore, this length HP would be 200 minus X. And it's 200 minus X because that length of the cube, it says in the question, is 200. Now what we're going to look at is a tetrahedron, and that is a triangle pyramid. It's going to be F, G, M, and P. So visualize that tetrahedron right in there. Now the volume of a tetrahedron is equal to 1/3 the area of its base multiplied by the height. So let's first look at it like this, where the height is actually GP. So the height is going to be X. So we can calculate this to be 1/3. So the area of the base, that would be the triangle FMG. Now since FG and GM are both 200, we could figure out the area of that base as simply 200. So FG multiplied by GM, which is 200, and then multiplied by a half, since 200 and 200 will give us the area of that whole square, multiplied by a half to get that triangle for the base. And then the height is this height here, which we've labeled to be X. So that gives us a volume of 1/3 times 20,000 X. All right, so let's remember this. We're going to come back to this later. What we're going to do now is sort of take this tetrahedron and put it on its side. What I want the height to be, we're going to calculate volume again, but in this case, the height is going to be this perpendicular distance from the surface of this triangle, PFM, to G. So that's going to be our new height right in there. That's our new height. Then the area of the base, to figure out the area of this base, that base is going to be this triangle here, FPM. So I need to first find the area of the base of that triangle. So first let's find the length of FM. To find the length FM, I can go back and look at this triangle FGM. Now that's a right angle triangle right here. Since it's a right angle triangle, I can use Pythagorean theorem to say that FM is the square root of, this would be 200 squared plus, and this length would also be 200 squared. So that gives me a length of FM as 200 times root 2. Now we can also do the same to figure out this length FP if we look at the triangle FPG. That is also a right angle triangle. And so I can figure out what FP is by saying it is the square root of, well, here's FG, that's 200 squared, plus this height, which I labeled to be X, so plus X squared. So the length FP is equal to X squared plus 40,000, because 200 squared is 40,000. And by the exact same process, MP would be the exact same length. It would be the square root of x squared plus 40,000. Now, since FP and PM, or MP, are the same length, then we know this triangle that we're using for our base is an isosceles triangle. So let's call this midpoint right here T. Now it's getting a little messy in there, so let me redraw that triangle I'm looking at. What I'm looking at is that isosceles triangle. So this is P, this is F, this is M, and right in between at the midpoint we have T. Alright, so I can connect PT. Since I know that that is the midpoint, I know these two lengths are the same. And since it's an isosceles triangle, I know that these two lengths are the same. Alright, so I'm going to free up a little space to work, but remember that volume. We're going to come back to it. Alright, so let's look at this right angle triangle, PFT, and I can calculate what PT is then by using Pythagorean theorem. Once again, where it's the hypotenuse squared minus one of the sides. So the hypotenuse we already know, that's PF, which we figured out right there. So it is going to be the square root of 200 squared plus x squared, which just gives us x squared plus 40,000, minus this distance FT, which is half the distance of FM. So we know FM, so FT is going to be half of that, which is going to be 100 root 2. So we have 100 root 2 squared. Alright, so 100 root 2 squared is going to be 20,000, and so 40,000 minus 20,000 is just 20,000, and we're left with the length of PT as x squared plus 20,000. So now I can calculate the volume of this tetrahedron if FMP is our base. So it's going to be 1/3 times the area of the base, where the area of the base is this triangle here. This is our base, PFM. So the area of that would be 1/2 the base, which is FM, which we know is 200 root 2, times the height of that triangle, which is PT, which we just solved for right here, is the square root of x squared plus 20,000. And then multiply all of that times the height. The height here is this perpendicular distance from that base to G, and we are told that in the question. It is 100, so times by 100. So this is the volume of that tetrahedron. But we also already calculated the volume of that tetrahedron before, when the base was this triangle FMG. So what we're going to do now is equate this volume with that previous one that I told you to remember. Alright, so now that we've equated those two volumes, we can rearrange and solve for x. So we can first cancel 1/3 on both sides of the equation. So on the left side we'll have 20,000x. And on the right side we're left with 1/2 times 200, which is just 100, root 2, times the square root of x squared plus 20,000. And then we have times 100 on the end. So I can divide both sides by, here we have 100 and 100 again, which is 10,000. So when I divide both sides by 10,000, we're going to get 2x is equal to root 2 times by the square root of x squared plus 20,000. Now I don't like those square roots. Let's square both sides. That's going to give us 4x squared is equal to 2 times x squared plus 20,000. Okay, let's distribute, collect like terms. So this is going to give us 2x squared. Subtract it from both sides, and we're left with 2x squared and 40,000. Divide both sides by 2. We have x squared equals to 20,000. Take the square root of both sides, and we only care about the positive value. Since x is greater than 0, it's a length. We will get x equal to 100 root 2. Now, since x is 100 root 2, and we know that HP is 200 minus x, we can now solve for HP. HP is equal to 200 minus x, which is 100 root 2. And when we plug that into our calculator, rounded to 2 digits, we get 59. So our answer is D.